Hi, Ravindra. Yes, few minutes, bro. Okay, just couple of minutes. Hi, Sneha. Hi, Jane Mandia. How are you all? Raghavendra, you can turn off your video. Quick open. Guys, I'm audible, right? Let me know in the chat box once. Good evening, Soumya, Sneha. Hi, hello everyone. Good evening. Am I audible, right? Let me know in the chat box once. Am I audible? Hello. Am I audible? Guys, please give a response in the chat box. Good evening, Sneha. Guys, start our session within 2 minutes. Okay, please be right. And meanwhile, I want to know, yes, it's working, but nobody is responding. Hi, Ishwari. Hi, Impana, Purva, Raghavendra. JNV Mandya, Sanjota. Guys, can you give a line in a chat box? I'm audible, right? Good evening. अरे गुड इवनिंग बाद में बोलो, पहले ये बोलो मैं ऑडिबल राइट. Yes, thank you, Ishwari, much for response. Yes, it's a pretty well. Yes, thank you so much. And meanwhile, if you people are getting breaking voice means, let me know immediately. Okay, don't wait for a long time. Okay. Okay, that's great, Ishasanya. Good. Guys, we'll start. Actually, in the last class, मेरा laptop shut down हो गया. For that reason, I couldn't able to complete my session. Okay, no worries. Today we're going to learn more about that point. Okay, I will clear that point and I will move on to the next concept, which we are going to about to start today, Gauss law in electrostatics. Okay, today we are going to start about the Gauss law and its own application and few good numericals also. Okay. And meanwhile, we have to wait for the 2 minutes. Yes, good evening, Jansi. Good evening. Then, how are you all? Yeah, I'm also good evening. Sujan, good evening, bro. Good evening. Yes, guys, we'll start our session today's one. Before that, let us take a quick recap what we discussed in the previous class. जल्दी से जल्द recap लेते हैं, right now. Okay, in the last class we discussed about the electric flux. Before that, we started up with the area vector, right? Area vector क्या होता है actually? If you consider this a area, okay, on this area if you're going to consider any small area, इसके लिए एक particular direction भी होता है, correct ना? That particular direction is known as, which is showing by that area, is called the area vector, correct now. Area vector always, guys just remember this point also. If you are going to consider this an area, okay, area vector is always be perpendicular to the surface area, always it is 90 degree. Okay, देखो इधर, this is area, मान लो this is my phone, okay, this is my phone, this is a area vector pen. Okay, if I'm going to change my area, means it is not visible. हाँ, not हो रहा है इधर, problem इधर, this is area, okay, this which I'm keeping on this one, this is the area vector. If I'm going to change area, always to area vector. Okay, that's it. And then we discussed about the electric flux. Electric flux, okay, this is the area. Okay, this term is area. These are the electric field lines. Okay, these are the electric field lines which pass through this area, also as an electric flux. The number of field lines which is passing through this area is called the electric flux, right? And then yeah, I think this is one of mathematical derived like this. Flux value will be equals to E dot dA. Okay, you're going to expand this flux value will be E dA cos theta. Actually, your flux is depending upon the theta and also, and then electric field lines also. मान लो, these are the 4 lines which are passing through this one area, small area है इधर. Okay, if you take field lines will increases, means if field lines value increases means E value increases means number of field lines increases. And in case of, if you're going to increase the area also, okay, flux value will be okay. Just this is an interesting point. This is a one fixed area. Here 5 electric field lines are moving. Something what flux we got 5A. Okay, same flux hai of field lines hai, electric field lines. If I'm going to changing the area, keeping this much of bigger one, now tell me flux whether it is decreasing or increasing. If you're going, oh shit, now is my voice is clear? Tell me now, is it my voice clear? Okay, then it's fine. Yes, okay, good. Screen is not visible. Ayo Bhagwan, just a minute. Now check it once. Is my screen is visible, right? रिकल का एक स्लाइड है, इज इट विजिबल? नो, अरे यार क्या हो गया इधर? जस्ट अ मिनट. Now check it once. Yes. Quickly let me know in a chat box. Yes, right. Now it is visible. Yes. Okay. Thank you. That's great. Okay. And then हाँ electric flux हो गया, कोई problem नहीं. Okay. Electric flux value we got. Phi value will be EA cos theta. Phi which quantities के ऊपर depend करता है, मैंने बोल दिया, कोई problem नहीं. Keep that point. And then relation between electric field and as well as the potential we got. Correct ना? Electric potential and field line के लिए E is equal to minus dV by dr मैंने बोल दिया था. E is an electric field, it's a vector quantity. dV it's an scalar quantity, but this dV by dr is there no total dV by dr. We call this one as an potential gradient, right? This potential gradient is an vector quantity. It's an vector quantity, don't forget. And work done we can represent in terms of Q into V also. How? Potential is equal to work done by unit charge. Work done if you want means Q को इधर multiply करो, Q into V is equal to work done होता है. Done. And then area vector के साथ मैंने flux भी yesterday explain किया था, few points. How? मान लो I'm writing here, देखो, this is area vector. Okay, this is the area vector will be in this direction. Okay, मान लो electric field lines also moving in this direction. ये दोनों के बीच में एंगल कितना हो सकता है इधर? मैक्सिमम मींस, let me know in a chat box what will be the angle between area vector and as well as the electric field lines here. अरे यार 180 ना, कहाँ से 180? दिस इज एरिया वेक्टर, हाँ 90. अरे यार how it will be 90? I'm asking between these two. देखो इधर area vector in this direction, no, right? And as well as the electric field also in the same direction. Angle between them will be equal to 0 degree. 0 degree, right? थोड़ा ध्यान रखो भाई. This is 0 degree. Okay, if in case मान लो this is area. Okay, right? Now I'm taking area vector in this direction. सर कैसे होता है? ऐसे होता है भाई, देखो ऐसा एक डब्बा रख दो, इसका एरिया वेक्टर इधर होता है, इसका एरिया आई एम टॉकिंग नाउ. Okay, area will be in this direction. Okay, electric field lines again they are passing in this direction. Electric field lines, this is the first area A1, this is the second area A2. Now tell me, this is the electric field direction E. Between the electric field value and as well as the second area, what will be the angle? Angle क्या हो सकता है इधर? Yes, right Rajat, right Yashaswini. Now it will be 180 degree. 180 degree, correct now? Based on the angle, the flux value will be changing, right? No, keep that in your mind always, right? And also I told you that if the value, okay, theta value between 0 to 90 degree, then flux will get positive, and theta value will be 90 degree means flux value will be getting 0 because cos 90 value 0 hota hai in 90 degree. And if the value theta value lies between 90 to 180 means flux be negative ho sakta hai. Right. Okay, this is the point actually about to complete in a last class, but unfortunately my laptop crashed, means breakdown हो गया मेरा लैपटॉप का चार्ज. ओके, इसलिए मैंने नहीं करा. ओके, कोई प्रॉब्लम नहीं. Hope it is understood to everyone, right? All these concepts are understood, right? Up to this point, electric flux. Let me know quickly in a chat box. Good Srujan, good Yashaswini, good Purnima. I'm expecting maximum responses, guys, in a chat box. Okay, Jansi. Okay, if you people are understood means I have a question. Okay, quickly drop your answer in a chat box, which is the correct option among these four for this question. Electric potential V at a point, at any one point, at a distance r from the charge q varies as. Good, Rajat. I'm talking about electric potential. Right. अरे यार, इधर क्वेश्चन भी थोड़ा पूरा नहीं हुआ है, करेक्ट ना? As per my knowledge, क्वेश्चन भी पूरा नहीं हुआ है. Because actually you people are selecting q by r square. Yes, it is correct only. But here there has to mention one more point, whether this is for a single charge or a dipole. Right? They are not yet mentioned. Right? That's why try to find out the question whether it is correct or not. Okay? If it is a single charge, no, single charge के लिए potential होता है k q by r, means q by r होता है. If it is a dipole means this is for single. If it is a dipole means potential value will be k q by r square होता है. Correct ना? मान लो this is for a single charge. Okay, single charge के लिए correct option will be now option A. Clear ना? What is the mistake in this question? I informed you all, right? And if you still have any confusion means let me know in a chat box. Option D कैसे हो सकता है यार? Option D नहीं हो सकता है. Sujan, how it is possible? Option D. That will be potential energy for a group of charges. Is it clear, right? The point what I explained here, is it clear? Good. Good. Good, yeah. Well. Okay. We'll learn one more concept today, Gauss law. Okay. Gauss law we required to find out the electric field intensity. Okay. Whatever the material we have, okay, on that material if you distribute the uniformly charges means we can easily find out the electric field intensity by using a Gauss theorem. Okay, Gauss theorem है. क्या है Gauss theorem? According to him, guys, just मान लो इधर this is one charge, okay, plus charge है. Okay, plus charge के वजह से क्या होता है? Electric field will be moving radially outward direction like this in all the direction. Okay, इसके वजह से in all the points, if I'm going to take this point A, in this point some electric field intensity will be creating by this charge. If I'm going to take here means at the same distance, here also I will get a electric field intensity. Correct ना? Like this electric field intensity find out करने के लिए, okay, एक simple का तरीका बोल दिया है इन्हें. क्या point you have to find electric field intensity? No, draw one Gaussian surface. Gaussian surface means it's an imaginary surface based on the structure we need to draw. मान लो इधर एक स्पीयर है, मान लो स्पीयर है, स्पीयर के अंदर चार्ज है मींस एट दिस पॉइंट, मान लो एट दिस पॉइंट ये के ऊपर आपको इलेक्ट्रिक फील्ड इंटेंसिटी फाइंड आउट करना है. मींस एट दिस पॉइंट ये यू हैव टू ड्रॉ वन Gaussian surface that is also should be in a sphere के जैसे होना चाहिए. Okay, similar structure we required on symmetry structure. Okay, like that we need to draw. By using this sphere we need to find out the electric field intensity. ये law बोल दिया इन्हें, that's why we call this one as a Gauss law. Okay, we'll going to discuss about that one in this class. Okay, Gauss law देखो इधर, a surface integral of a electric field intensity or any closed hypothetical surface in a free space is equal to 1 by epsilon naught times the net charge enclosed within it. किसको आता है ये से पढ़ने से, right? I will explain this one in a bit by bit. Okay, मान लो this is one sphere. Okay, इसके अंदर एक चार्ज है. रजत, wait. wait bro, wait, I will tell you. इसके अंदर एक चार्ज है. Okay, at this point ये के ऊपर if you want to find out any electric field intensity means first thing we need to do, we have to draw a Gaussian surface. What is this? लिख दो guys. First thing you need to do, draw a Gaussian surface. Okay, Gaussian surface को create करना है, right? After this one, whatever this area is there, no, whatever the area you drawn here for the Gaussian surface, this area you have to find out. That's why he told that in a closed integral आता है in 12th standard only mathematics में. Up to that point, just imagine like that. Closed integral means in the complete area what we need to take here. Okay, in a closed integral, E dot dl, it is nothing but guys flux. It is nothing but flux. Okay, this value will be equal to 1 by epsilon naught times the charge inside that closed surface. Okay, देखो इधर 1 by epsilon naught, it is nothing but the medium which is present inside that Gaussian surface. एक Gaussian surface है ना बाहर के वाला, right? In this Gaussian surface के अंदर कौन सा चार्ज है? Okay, उसका मीडियम लिखना है इधर 1 by epsilon naught टाइम इंटू क्यू चार्ज. कितना चार्ज है उतना चार्ज को इधर रखना है. ओके, अकॉर्डिंग टू हिम इट्स वेरी सिंपल. The flux value will be equal to q by epsilon naught or 1 by epsilon naught times the q we have to write. By doing this one, we can easily calculate the electric field intensity. Is it understood, right? What I'm saying, what I'm supposed to say here, is it understood? According to this law, in a closed integral of E dot dl, E dot dl is nothing but flux, guys. Just remember flux. E dl cos theta or E dA cos theta we written no in a similar way. Understanding right what I am saying? In a closed integral means ये पूरा का पूरा surface है ना, इसको integration करना है. We need to do integration for this whole surface. Okay, if you do that one, no, we will get a flux. Okay, this flux value will be equal to q1 by epsilon naught times the charge which is enclosed inside the surface. Whatever the charge will be present inside the surface, no, that one we need to write here. Clear, right? This is the Gauss law, guys. This is law, that's it. Law means if you are ruling your home means few rules you are going to keep in front of your home members, right? Those are the rules acting like a laws. Similarly, to find out the electric field intensity, Gauss actually a scientist hai. He given on rule, law. That law will be like this. Koi problem nahi. Just you have to think like this. Electric flux value will be equal to q by epsilon naught. That's it. By using this value, we will find out the electric field intensity also. This value actually equals to in a closed integral of E dot dl. E dot dl. I will tell you everything. What is E dot dl? Everything. Here, मान लो E dot dl in a closed integral means मान लो this is or else you take dA only. कोई problem नहीं. Here if I write surface area means इधर area को integration करना है. Clear है ना? I will explain this one by proving. I will prove the theorem. Then you will get to know how the Gauss law will come. Okay, we'll get into the Gauss law now. Okay, we will get a more idea about it. Just a minute. Okay, देखो इधर proof कैसे होता है guys. Okay, this is one of the sphere. Okay, sphere के center में I'm going to keep one positive charge. A positive charge के वजह से क्या होता है? Electric field lines will be moving in all the direction like this. Okay, if I want to find out the electric field intensity at a point P on the surface, इस surface के ऊपर एक point P consider करता हूँ मैंने. देखो, I will tell you where it is actually. The point P, where it is, guys? It is not coming. Just a minute. Okay, मान लो this is the point P. Okay, on this point P, I want to find out the electric field intensity due to this positive charge which is enclosed inside the surface. देखो इधर एक पॉजिटिव चार्ज है ना, ये चार्ज की वजह से ये पॉइंट पी के ऊपर इलेक्ट्रिक फील्ड इंटेंसिटी कितना होता है, दैट इज व्हाट एक्चुअली आई वांट टू फाइंड आउट बाय यूजिंग द गॉस थ्योरम. मान लो for that reason what I will do at this point P, I will consider a small area. Okay, I'm considering here one small area that is ds. Okay, uska area vector will be in this direction, area vector in the same direction of electric field value. Okay, and then due to this charge q, electric field also moving in a same direction. Right now देखो area vector will be in this direction and as well as electric field also in this direction. Guys, may I know what is the angle between them? Let me know in a chat box quickly. Zero. Right. Zero itself. Yes, Jansi. Yes, Rajat. Yes, Sujan. Right. Yes, Shashini. Right. Zero. Yes, Sajot. Right now. Now देखो इधर actually electric flux means कैसे दिखता. Okay, मान लो total electric flux means we will write this one as an E dot A cos theta. मान लो like this. Okay, here small area I'm considering means a portion of electric field will be coming here. Correct na? That's why the electric flux which is creating here also we can write this one as an d phi is equal to E dot dA, small amount of area into cos theta. Here theta value already you told me that 0, cos 0 will be maximum, then flux क्या होता है इधर E dot dA होता है. Correct ना? That is what I am writing here. इधर देखो first equation will be d phi value will be equal to E dot ds. Okay, and we know that the value of E, electric field intensity क्या होता है due to a single charge, k cube by r square ना, k cube by r square itself. This is what electric field value. If you want to write this one in a vector means you need to multiply one unit vector, and ds is the small unit area which we are considering here, and n cap is the unit vector of this area. No worry about this one. If you're going to multiply these two unit vectors, no, you will get value 1. You will get a value 1. Right? Next देखो 1 by 4 pi epsilon naught and then q ds divided by r square. ये दोनों का वैल्यू कितना इक्वल टू 1, राइट? एंड देन here come here. Okay, d phi value will be equals to 1 by 4 pi epsilon naught q ds by r square. Now guys look at it, देखो इधर, this is the flux which is happening only due to this small amount of area, whatever the area it is present here. No, there is a small area. Look at here, only for this area the flux will be d phi. If I want to find out the total flux for this surface means I need to apply the integration. I need to apply here integration. No, that's it. For to find out the total flux I will apply the integration, that is a closed integral. We call this one as an closed integral. Okay, closed integral means वो सरफेस का पूरा एरिया निकालना है हमको. क्लियर है ना? डी फाई करना है. इधर अगेन डी फाई का वैल्यू में 1 by 4 pi epsilon naught, q is constant and r is also fixed one. Area is only changing. We need to integrate this point, right? That's why I will take 1 by 4 pi epsilon naught q by r square outside of the integration, and I'm going to integrate the ds. Guys, let me know what is the integration of ds. Ds means here it is nothing but this is the small area. If you're going to integrate full area of this sphere means what you will get? Area of this sphere. Tell me in a chat box. What is the area of the sphere? That is volume. That is volume. 4 by 3 pi r cube is volume. I'm asking about area. Haan, right, Sujan. But 4 pi r square, that is not pi r square. Okay. Look at here. These things I'm going to keep here only. Okay, 1 by 4 pi epsilon naught q by r square. But if you're going to integrate this one, no, you will get 4 pi r square. Right, guys? Right. Okay, you will get 4 pi r square. देखो इधर 4 pi cancel, r square से r square cancel हो गया. Remaining term will be इधर q है, in numerator q, in denominator epsilon naught. Means इधर total flux value क्या आ गया हमको? It is equal to q by epsilon naught को equal आ रहा. This is called the Gauss law. Right? This is called Gauss law. Clear na? Means the flux value for any closed surface is equal to q by epsilon naught. And one more point I'm going to mention here, guys. Very easy trick I'm going to mention here. This q hai na, this q value we have to take enclosed one. Q enclosed means charge inside the surface. Okay, if charge will be inside the surface, then only we will get electric flux, or else we won't get any electric flux. Okay, electric flux value will be 0 हो सकता है इधर. Directly लिख दो. If charge will be not inside the Gaussian surface, मान लो this is Gaussian surface means white color which one I'm drawing here. Okay, इसके अंदर charge नहीं है, then charge value here will be 0. Then flux value क्या होता है? 0 हो सकता है. Is it clear, right? Let me know in a chat box once. Is it clear? Good. Yes, that too great, guys. That too great. Okay. I think you people are understood. मान के जा रहा हूँ next concept के लिए. Okay. Next concept क्या है? Okay. Before coming to this point, I would like to ask one question here. I will take an extra slide. Okay. Look at here, guys. Look at here. We need to find out the flux value. Flux value find out करने के लिए इधर मेरे पास एक cylinder है. Okay. Look at here. This is a cylinder. Okay. Inside the cylinder, electric field lines are passing. Okay. Electric field lines are passing. And this is first area. This is a second area. So no dances, this is first area, area 1. This is area 2. And cylinder has 3 areas. Yes, definitely, Rajat, I will explain. Okay, cylinder has 3 areas. This is one more area of the cylinder. That is a surface area of the cylinder. Don't forget this one. Okay, iska area I will call A3. So no dances. A1 का area A1 है ना, इसका डायरेक्शन इधर है. D A1 I will write a small area if I'm going to consider here means, and D A2 का area vector will be in this direction, D A2, and electric field direction will be in this direction. Correct ना? Now I want to know one more point here. Next point क्या है? ये area है ना, surface area. Surface area का area vector will be always perpendicular to outer direction like this. This is DA3 if I'm considering a small area here means. Okay, now let me know, guys, what will be the flux value here. Flux value कितना हो सकता है? Generally we know that flux means E dA cos theta. Yes, right. E dA cos theta. I will prove this one. Gauss law, how it will be helpful for us. I will prove this one now. देखो इधर E dA cos theta. For the flux one, I'm writing here means dA1 I will take for this one. Okay. Theta value will be here 0. Here for the first case, theta value will be 0. Then it will become flux 1 will become E dA1. Correct now? Okay, clear. And then this is for a first thing. If I'm going to consider for the second area, again flux 2 value will be equal to E dA cos theta. इधर थीटा वैल्यू कितना हो सकता है, इलेक्ट्रिक फील्ड इंटेंसिटी वैल्यू इन दिस डायरेक्शन, area vector will be in opposite direction. Here theta value will be 180 degree. Yes Srujan, right bro, right. Okay, if you put 180 degree means flux value क्या होता है इधर, minus E dA2 होता है, E dA2, दो फ्लक्स हो गए. Then coming to the third one, इधर देखो third point ऊपर वाला. Okay, third point में again flux 3 will be equal to E dA cos theta. Either actually electric field lines are moving in this direction, right, and the area vector will be in this direction, angle between them will be 90 degree. Yes, absolutely right, 90. Then phi 3 value will be equals to 0 हो गया. And then now what will be the total flux will be present here. देखो total flux find out करने के लिए हमको क्या करना है, we have to add all the flux because flux is a scalar quantity, right? The scalar quantity or vector quantity? Let me know now, flux whether it is scalar or vector. I want answer from your end. Good Jansi. Scalar one, correct now. If now we need to add all the flux, means total flux will be come out to be here phi 1 plus phi 2 plus phi 3. phi 1 का वैल्यू E dA1 प्लस phi 2 का वैल्यू माइनस है, देखो माइनस E dA2 एंड phi 3 वैल्यू 0, करेक्ट ना. इधर dA एरिया है ना, एरिया बोथ साइड सेम है, hence these two will be cancelled out. Then total flux value क्या आ रहा है, 0. Total flux value will be come out to be here 0, right? What I'm saying, are you agree with this one? Give a quick, yeah, right. Yes, now देखो how Gauss law is helpful to find out the flux. Okay, actually Gauss law or Gauss ने क्या बोल दिया था हमको, the total flux value is equal to q by epsilon naught. Okay, मान लो this is a Gaussian surface. Guys, I'm writing the Gaussian surface in this red color pen. देखो इधर dotted lines आ रहा है ना. Okay, this is a Gaussian surface which I'm writing here. Similarly, like a cylinder के ऊपर सिलेंडर रख दो, that is a Gaussian surface. Guys, इधर in this Gaussian surface, inside this Gaussian surface, is there any charge है क्या, बोल दो. Is there any charge present inside? I need response. Is there any charge? No, obviously no charge is there. Electric field lines are actually coming from infinity से आ रहा है, इसके अंदर कोई चार्ज नहीं है. Then flux value क्या होता है इधर, according to the Gauss, देखो charge value 0 divided by epsilon naught, 0 by anything will be 0. That's why we are using the Gauss law. Is it clear for everyone? Yes, if any charge is not present inside means flux value will be 0. That's it, done and dusted. Cool. Is it understood right for everyone? Gauss law का मतलब क्या हो गया, मतलब क्या है पता हो गया ना सबको. Take a screenshot if you want means immediately. Okay, I will explain one more concept about the Gauss law. Is it clear, right? Good. Are you getting bored? Are you getting bored? No, na? Okay, cool. If you are getting bored means I have few questions. We'll solve the questions. Okay, continuously we are talking about the concept means it is not good. Correct na? We have a question. We'll solve this one. देखो इधर questions क्या है? A small particle carrying a negative charge. A particle है. It is actually carrying a negative charge of 1.6 into 10 to the power of minus 19 coulomb. This is guys 1.6 into 10 to the power of minus 19 coulomb is suspended in equilibrium between the horizontal metal plate. Okay, एक metal plate है, horizontally metal plate suspended equilibrium between, okay, between, this is two horizontal metal plates, guys. Two horizontal metal plates. Actually, they are separated by a distance of 5 centimeter. Okay, having a potential difference of 3000 volt. Okay, across them, find the mass of the particle. Arey yaar, what is this? ಏನು relation है ಇಲ್ಲ. Okay, we'll solve this one. देखो इधर two metal plates है ना, they are separated by 5 centimeter apart. We'll draw this one first. देखो इधर, this is the first metal plate. Okay, and this is the second metal plate. Okay, drawing थोड़ा अच्छा नहीं है, adjust कर लो. The separation distance दे दिया है 5 centimeter. Separation distance 5 centimeter. Okay, and ये दोनों को बीच में, this is separation distance, ये दोनों को बीच में potential difference develop हो गया ना, वो भी दिया है. Potential will be between these two particles will be 3000 volt. Okay, and then yeah, a small particle carrying a negative charge is suspended equilibrium. Means इधर एक charge, a particle है. Okay, a particle के ऊपर, this is a particle, इसके ऊपर guys actually charge है ना, that is equal to 1.6 into 10 to the power of minus 19 coulomb. Equilibrium means it is not actually shaking or it is not actually moving anywhere, correct na? But this charge is a negative one, negative charge. This is all about the data which they given in the question, right? Now we need to find out what will be the mass of this ball or mass of this particle. We need to find out a bob का अथवा particle का mass we need to find out. कैसे find out करते हैं? How to find out this one? Okay, देखो, actually this is in equilibrium means, okay, इसके ऊपर एक force लगता है downward direction में. Okay, in downward direction on this particle there is a force will be existing, that is called weight of an object, m into g. Correct na? M into g. We can write like this. This m into g is there? No. Yeah, sorry, m is equal to, sorry, w is equal to weight. Sorry यार. देखो इधर. W is equal to m into g is there. mg, right Rajat. Okay. Mass इधर ही है. इसको कैलकुलेट करना है हमको. That's it. W is nothing, guys. Force. I'm going to write this one as an force is equal to m into g. Okay, I will take this g to left hand side, then it will become f by g is equal to m. That's all. Mass आ गया, but values रखना चाहिए ना. इधर g है. Okay, g का value try to take always 10 meter per second square. It's an acceleration due to gravity. Good. And f value, we don't know this one, but in electrostatics, guys, f value will be always be. Let me know what is the value of f now. Yeah, 9.8 also it is good. Jan's right. Force, how are you going to take the force value in electrostatics? Yes, good Rajat. Okay, it is nothing but E into Q. Correct na? Okay, substitute karo idhar. Then E into Q divided by G is equal to M हो गया. Right bro. Right Jansi. Right pa. Okay. Now देखो इधर charge पता है, acceleration due to gravity पता है, but we don't know the value of E. Right? How to find out the value of V? E. E value कैसे जानना है? इधर देखो distance दे दिया है, potential दे दिया है. Is there any relation between potential and electric field value with respect to the distance? Yes, exactly right. Yesterday only we talked about this one. Electric field intensity is equal to minus dV upon dr. Correct ना? Substitute करो इधर. Substitute करने से पोटेंशियल हमको पता है कितना है 3000 वोल्ट divided by distance between them will be 5 centimeter, means 5 into 10 to the power of minus 2 meter, right? What I'm saying. And then in numerator देखो इधर I will write this one as an 30 into 100, 3000 है ना, इसको ऐसे रख दिया मैंने, divided by 5, this 10 to the power of minus 2 is there, no, I will take to numerator, it will become 10 to the power of plus 2. Simplification, 5 ones are 5 6 are, means minus 6 into this is 100 is nothing but 10 to the power of 2 plus 2, and 10 to the power of plus 2 means 10 to the power of plus 4 हो गया. This is electric field value. And also guys, electric field value के लिए हमको SI यूनिट पता था, electric field intensity के लिए फार्मूला SI यूनिट क्या था, न्यूटन पर कूलम लिखते थे. But don't confuse here guys, actually here potential है, this is V means potential means volt divided by distance is nothing but meter, means guys volt per meter also SI unit for electric field intensity, right? Electric field intensity के लिए ये भी SI unit बन सकता है. If I'm doing fast means please do inform me. Okay, मेरे कैमरा भी स्विच ऑफ हो गया है. Okay, cool. We got electric field intensity value. अरे यार क्या हो गया इधर, correct ना? Substitute this value here again. Then देखो m value will be equals to E value कितना है, minus 6 into 10 to the power of 4 divided by G. G value रख दो इधर 10, काम खत्म, into Q value कितना है 1.6 into 10 to the power of minus 19 coulomb. Okay, and calculate this one, simple सा है guys. देखो इधर क्या कर सकते हैं इधर. Okay, if I'm going to take this 10 numerator means it will come minus 10, 10 to the power of minus 1. Then if I'm going to add here means, okay, I will multiply these two. Okay, if I'm going to multiply these two means 16 6 are 144, right? 16 into 6 96, sorry 96 sorry यार. Okay, 96 means it will be 9.6 divided by इधर 10 है ना, ये इधर ही रख दो 10 into numerator, इधर देखो 10 to the power of 4 10 to the power of minus 19, it will be 10 to the power of minus 15. ये 10 से डिवाइड होता था मीन्स क्या होता है इधर 0.96 into 10 to the power of minus 15 kg बन रहा है, right? This is the value of mass which is actually suspended between a two parallel plates. मालूम हो गया ना कैसे कैलकुलेट किया. एक ही क्वेश्चन, almost all 3 to 4 concepts I mingled here. अच्छा है ना क्वेश्चन? Let me know how is the question. Is it good, right? It is giving complete idea about this mechanics also here. Force कैसे लेना है, डर गए थे. No need to worry yaar. Okay, try to practice more and more. Okay, one day definitely you people will become a classic level in physics, right? But practice needed much more. That's too great. Even I'm also not a clever minded for a physics. I'm also practicing a lot for do simplification of the problem, and when I'm good giving a idea about the concept, no, I'm also trying to search few things how I can deliver in front of you. It should be easier to you people like that. Okay, होता है, time लेता है. Okay, but you people don't have too much of time, you have only 1 year of time. Right? Okay, here I will give one homework problem guys. This is actually आपका homework problem है. I will upload this notes in a drive. Okay, try to download the notes and find out the answer for this question. Okay, I will discuss one application based on the Ohm's law, Gauss law now. Is it okay for you, right? Shall we discuss one more concept based on the application of Gauss law? Previous slide, Kiran. Which one, bro? Is it one? Take a screenshot, bro. If you want means immediately, if you want means take a screenshot or else you can download this one from the now only. Okay. ओके एप्लीकेशन ब्रो गाइस सुनो ध्यान से एक एप्लीकेशन डिस्कस करते हैं इलेक्ट्रिक फील्ड इंटेंसिटी ड्यू टू एन इनफिनिटली लॉन्ग स्ट्राइट चार्ज्ड वायर ये क्या है सर देखो ऐसे होता है दिस इज द इलेक्ट्रिक infinitely long wire which is actually distributed over here uniformly charged one here. Okay, means we are distributed the charge uniformly throughout the length, doesn't depend on length. No flux flux will not depend on the Gaussian surface. Gaussian surface के ऊपर depend ही नहीं करता है. You may be take small area or you might be take a larger area, nothing problem. Okay, मान लो देखो इधर. Okay, I will explain this concept only, that one. Okay, देखो इधर guys, due to this electric wire, a wire के ऊपर charges are uniformly distributed. Actually these are extending up to infinity. Very long wire है. Okay, due to this wire what will be the field intensity, means E value क्या हो सकता है, we need to find out, or else we need to find out what will be the flux. Flux find out करने से E आसान से आ जाता है. देखो क्या करना है. Now I need one Gaussian surface here. According to Gauss आ रहा है means इसका एक surface को भी लेके आना है हमको. Okay, let me know guys, for this like this structure, this is wire means, okay, for like this structure what will be the suitable Gaussian surface? What will be the suitable Gaussian surface? Right, obviously we can't draw the sphere here, it will not give us symmetry, correct na? That's why we have to choose one cylinder shape of Gaussian surface, right, like this. Is it visible? Right, थोड़ा visible है, adjust कर लो. Okay, like this. देखो इधर कैसे लेता हूं मैंने. देखो, this is the Gaussian surface which I'm taking. Guys, this surface है ना, आपको जितना लेना है ले लो एरिया में, कोई प्रॉब्लम नहीं, right? And then Gaussian surface is a closed surface around the charge distribution such that electric field intensity has a single fixed value. Every point of the surface will be same. Okay, every point के ऊपर मान लो on this point, top of the point, in this point or in this point you take. Okay, due to this charge electric field intensity it should be same. Like that, in a symmetry way we need to choose the Gaussian surface. Gaussian surface choose किया आप. Now guys, actually electric field lines कैसे जा रहा है देखो, ऐसे radially moving outward direction, correct ना? ऐसे भी जाता है. Okay, how much amount of electric field lines which we are moving in this direction, same amount of electric field lines are moving in this direction, right? That's why they might be cancel each other, I don't know, we'll calculate. Okay, now देखो, this is the distance x from the wire which has a charge where we need to find out the electric field intensity. Next देखो, this is the total length of the Gaussian surface which we are taking, and this is the first area. Guys देखो इधर, this is the first area which we are choosing. इसका area vector किधर हो सकता है, in this direction में होना है ना. देखो, this is the area vector, small amount of area ds. This is the first area. Okay, second area. Okay, and then electric field lines, actually I told you now they are moving downward direction. देखो, due to this charge here electric field lines are moving downward direction. First area हो गया. Come to this second point, B is the second area. इसका area vector will be opposite direction to the first area, and again electric field lines का direction will be perpendicular to that one. हो गया दो एरिया. और एक एरिया आता है इधर, किधर आता है, सरफेस के ऊपर, इसके ऊपर है ना, ये भी एक एरिया है. ओके, सिलेंडर में टोटली 3 areas will become, don't forget. Okay, third area I'm going to take here. Okay, इसका area vector will be acting upward direction, and electric field lines also acting in the same direction. No, इधर plus charges है ना, right? Plus charges means electric field lines also acting in a same direction. Clear now up to this point? Is it clear for everyone how I took the Gaussian surface and how I'm taking the angle between the area element and as well as the electric field intensity? No, that is different. That is different, bro. That is different. Actually, we calculated that one. Don't get confused here. Okay, we calculated previously to explain the Gauss law. Inside the surface, I didn't consider any charge that time. These charges are not available that time. Right? I took a electric field lines. They're actually passing like this. Right? Don't get confused. Clear na Rajat? Yes, that's great, bro. Okay, देखो इधर from Gauss law. Actually Gauss law क्या बोलता है? अरे यार, हाँ, इधर देखो. Total electric flux will be equals to, in a closed integral, E dot ds is equal to Q by epsilon naught. Actually, this law you have to, at any cost, you have to learn, because 2 mark का question will be आता है इधर. Clear ना CBSE के लिए. And then here 3 surfaces are there. That's why we need to integrate 3 surfaces also. Let us go one by one. Okay, surface area E dot ds value will be equals to, देखो इधर, for area 1, ये area के लिए E dot ds, good. Next area E dot ds, second one, and coming to the third area E dot ds. We are adding the all the areas and flux. Okay, next देखो इधर, flux here area को define करना है along with the angle. First one E ds cos theta आता है. इधर देखो angle will be between these two will be 90 degree ना, 90 degree cos 90. And second one also area vector in this direction, electric field will be in this direction, angle between them will be 90 degree. And then coming to the third one, again third में देखो इधर है third area, ds area will be upward direction, electric field lines also in a upward direction, means angle between them will be here 0 degree, means here cos 0 होता है. Correct ना? देखो इधर cos 90 means the value will be 0. Again second area का cos 90 value will be 0. कोई problem नहीं. Remaining thing is that guys, third area means surface area से क्या मिल रहा है हमको? Flux मिल रहा है. Flux is actually we are getting from the surface area here, surface area of cylinder. Correct ना? Okay, cos 0 degree will be 1 and remaining thing will be EDS. Correct ना? But we need to integrate all this area. ये थोड़ा area है, थोड़ा सा area है, but we need to integrate all the area, means may I know what will be the area of cylinder. Okay, area of cylinder क्या होता है? DS means छोटा सा element area. Total surface area of the cylinder क्या हो सकता है? Yes, good Purnima. This total area of the cylinder will become out to be surface area 2 pi RL. RL means R means yeah right. Okay, that is actually volume, bro. You're saying volume. 2 pi R plus H, not that one. Okay, R means it's a radius one. L means it is the length of the cylinder. Okay, means if you're going to integrate this ds, no, you will get 2 pi RL, right? देखो इधर E into 2 pi RL. Correct ना? What is this actually? This is equal to flux. Flux के लिए equal हो गया है. Okay, देखो up to now if you have any doubt, let me know in the chat box, or else be concentrate here. One more point I want to establish here, because I have to find out the electric field intensity. No, इधर है electric field intensity. Now I want to reveal this electric field intensity. देखो क्या करता हूं मैंने. देखो इधर we got one equation here. What is that? E into 2 pi RL value will be equals to flux. Correct ना? Flux के लिए equal हो गया. Then we can write E dot 2 pi RL will be equals to flux according to Gauss, means flux value will be Q by epsilon naught. Q by epsilon naught होता है, means we need to equate this one for the Q by epsilon naught. Right now, but देखो इधर, here what we consider, no, Gaussian surface, this Gaussian surface only for a short area element, means only this is valid up to this much, this length. What about the infinite length? पूरा infinite length के लिए हम लेना है ना. If we are not taking that one for infinite, means it is not an answer, right? For that reason क्या करना है इधर, we need to express this one in terms of charge density, linear charge density. कैसे लिखता है उसको? Linear charge density lambda will be equals to Q by L, charge per unit length. Charge per unit length is the linear charge density. I told you that surface charge density means charge per unit area होता है, and then volume के लिए rho, charge per unit volume होता है. But it is a length, no? That's why we need to take this value. Clear है ना? Now देखो इधर, in the place of Q, इधर Q है ना, Q के लिए ऑपरेशन करना है, means इधर Q value we need to take a function, then take L to left hand side, then lambda into L will be equals to Q. Substitute this value in this equation. Okay, if you substitute this value, no, E dot 2 pi RL value will be equal to lambda into L divided by epsilon naught हो गया. Clear, right, what I am saying? And then this L cancel, and I want to find out the electric field intensity. That's why take this 2 pi R to right hand side. Then it will become, देखो इधर electric field intensity will be equal to lambda divided by 2 pi R into epsilon naught, right? This is the electric field intensity, but it is highly difficult to remember. For that reason, what I will do, no, देखो इधर क्या कर रहा हूं मैंने, small change I will do. Lambda divided by 2 pi epsilon naught I will multiply one side, 2 pi epsilon naught into R I will multiply separately. R I will multiply separately. Then later on, both the side I will write, both not in a both side, actually in a numerator and denominator I will multiply and divide by 2 करूंगा. If I did like this, no, what I will get, देखो इधर 2 lambda divided by 2 into 2 means 4 pi epsilon naught into R. देखो इधर 4 pi epsilon naught is there, no, 1 by 4 pi epsilon naught. We can write this one as an K, and remaining 10 will be 2 lambda by R. This is the value of electric field intensity for a straight conductor. Means yes, right Purnima. Okay, straight uniformly charged infinite length conductor. You have to remember this one at any cost. This is very important for your board, even board exam के लिए भी बहुत important है. That's why you have to remember this one. Clear now this concept, how I derived this one? Is it clear for everyone? Good. How was the class? Yeah, it's cool, no problem. I think it's been my time. Yes, that's great, bro. Okay, right. Welcome. Okay, and one more point, guys. Electric flux के लिए, whatever the surface we are taking, no, that surface area will not affect the flux. Gaussian surface will not affect the flux. It is your wish how much area, how much sphere area you want to take, you maybe take. How much cylindrical area you want to take it, no problem. It won't disturb the value of flux. Flux के value depend नहीं करता है उधर. Okay, I think time up. We'll see you in tomorrow class. Okay, bye bye. गाल करे क्या है?